Next up is Alan Johnson, who's going to talk about half the Earth and 1/8 of everything else.
Yes, thank you. Okay, so my title was Half Earth, the 1/8 Principle, and the Ethics of Collective Restraint. So to summarize briefly, I'll maybe define those terms. The term half Earth is an idea that has been put forth by a number of people, but most notably, I guess, by the Harvard evolutionary biologist Edward Wilson, E.O. Wilson, has a book by that title. So the idea being that we should reserve half of the Earth's surface, half of the land and sea for nature, essentially. And the 1/8 principle refers to a paper published by astrophysicist Martin Elvis and philosopher Tony Milligan, where they looked at resource exploitation in the solar system. And they basically came down to advocate that we should set aside, that we should at most exploit 1/8 of the resources of the solar system, saving the remaining 7/8 as wilderness, as they called it in the paper. So these two principles are both calling for humans to essentially exercise some sort of restraint collectively, to leave parts of the Earth or the solar system and its resources unused. They offer a variety of different reasons for doing that. For Wilson and many other conservationists here on Earth, the justification often does hinge on the intrinsic value of nature and ecosystems themselves, but it also relates to the ecosystem services that are provided by natural ecosystems. For Elvis and Milligan, really, it's just sort of a prudential argument that once a space economy takes off, it's likely to grow exponentially. And by the time you've exploited 1/8 of the resources of the solar system, you're only 3 doubling times away from using up everything. And so there's sort of the potential argument that you should halt at that point and switch to a more sustainable, steady state economy of some sort without continuing that exponential growth in resource consumption. And so, I wanted to look a little bit at how you could justify an ethical principle to actually limit resource consumption like that. I have a couple other philosophers that I have done some work on this that I cite. Baylor Johnson put forth a paper where he argues that if we're dealing with a situation of common pool resources, some sort of a resource that everyone in principle has access to, and yet there's as Garrett Hardin famously termed it, the tragedy of the commons, that everyone tends to exploit the commons until it becomes depleted, and that leads to a degradation of the resource pool, degradation of the environment for everyone. So how do we avoid that? And what's the ethical motivation for that? Baylor Johnson argues that we don't have an individual duty to limit our own resource consumption, because we can't reasonably expect that work. If I've cut back on my resource consumption, there's no guarantee that others will cut back. But we do have an ethical obligation to work towards some sort of cooperative system that would put in place norms or a system that would regulate resource consumption. And I don't know, I could go into that a little bit more. I guess my final comment, I'll say that, looking at the existing space policy, clearly the Outer Space Treaty does refer to space as being something that should be used for the benefit of all countries, the province of all mankind. So there's at least a spirit in there of common benefit. Recently, in the US, both under the Obama and the Trump administration, there has been more emphasis, it seems like, on removing barriers to exploitation of space resources rather than, and President Trump signed a executive order that explicitly states that the US does not view space as a global commons. But despite that terminology, I think that in fact, at least in the sense that Garrett Hardin uses the term, it really is a commons, and we need to find a way to manage those common resources. So I think I've probably used up my time for summary, and be glad to answer questions.
Okay, Jim.
Thanks for the talk, Alan.
Thanks.
I wonder if the need to think about conservation is even more pressing. It seems like you've adopted this wider scale, at least the one that Milligan and Elvis point to about, thinking about long term, what's going to happen if we're not careful. But these problems also arise on much shorter timescales as well. In terms of, say, space resource use, we're only going to be able to use the resources we can get to at any given time. And it seems like our ability to even access anything is going to be very restricted. And so if we're only going to have a tiny little bit of any new resource pool at any given moment, it matters, how well we use what we have. And so it seems like, there's a very much, at any moment, conservation is a concern that we ought to have, for purely prudential reasons, over and above any value we might think inheres in these environments. I'm just wondering what your sense is on that side of the issue.
No, I think you're exactly right, and you're right. I mean, I did phrase it mostly in terms of Elvis and Milligan's argument, which is looking at centuries long period probably of expanding to the entire solar system, and they don't say much within that paper about which 1/8 we preserve. There's no real consideration. I think that's a real crucial element, and you're right. At any point in time, there's going to be a progressively greater set of celestial bodies accessible to us, different places, and how do we implement something like a 1/8 principle as we go along? Does that mean we just exploit everything to what we can get to until we exploited 1/8? No, that's probably not what they intended. Does it mean that they do say in the paper, they explicitly aren't saying that we necessarily need to leave 1/8 or only exploit 1/8 of every object? We might exploit, totally exploit some asteroids and, leave others completely untouched, perhaps, so. But I think you're right. These questions will come up much more quickly, and that's where we need to start developing, the principles for how we're going to use them wisely.
Catherine, did you have a question? Okay. Well, I'm gonna ask a question then, and this is kind of an unfair question to you, Alan, but I'm gonna ask it anyway. Um, I find it strange when people make a proposal like we should leave 7/8 of all the stuff beyond Earth untouched in order to preserve wilderness or something like that. Um, if you were to put that forward in a public venue, it would be, I think it's an understatement to say, massively unpopular. Now, that doesn't necessarily mean it's wrong. I mean, people could be misguided and they could be stupid and all that kind of stuff. But on the other hand, it does seem to me that at least it at least puts the burden of proof on the person who's advocating that to demonstrate why it's really morally imperative that we do something like that. Because the amount of resources you're talking about, and I know that resources is a loaded term, but the amount of resources you're talking about is astronomical, right? So I'm just
Right.
curious to see what you have to say about that, and maybe other people want to weigh in as well.
Yeah, I'd say a couple of things. First of all, 1/8 of the resources of the solar system is already a lot of resources. And I think Elvis and Milligan do a pretty good job of showing that gives us a lot of material to work with to support, a lot of things that we could imagine wanting to do for a long time. So it's maybe not as restrictive as it sounds. I mean, yes, we're leaving 7/8 untouched, but what do we really need? When are we going to need to access that 7/8? But and then of course, their other main point is that even though um, 7/8 seems like you're leaving quite a bit, if resource consumption is actually growing exponentially, um, you know, it may not be that long until you're then going to completely deplete the resources of the solar system. And their argument is that once we've depleted the resources of this solar system, it's a big leap to get anywhere else, find new resources. And so, that we really don't want to run out of resources in the solar system. But yeah, I don't know. I guess those are my two comments on that. See if anyone else has anything else to throw in on that.
Catherine, you raised your physical hand in the old school way. I'm assuming you want to be called on.
I did, yeah, sorry about that. Just because Martin Elvis is a colleague of mine and we've talked about this. And so he's an astrophysicist who's actually extremely interested in space development. I mean, because he views that the future of astronomy, depends upon expansion into the solar system. So he's not anti-development, but he's in favor of careful development. And because he's a number cruncher, so what he sat down to do, and this is also after running a workshop on space resources and collaborating with a number of different people. So he sat down to sort of just compute, just strictly crunch the numbers on how quickly the resources would run out. So he's not actually arguing from ideology, and I'm feeling like some of you are reacting to him ideologically. His argument is it's miracle. And he said to me himself, he was shocked by how fast the solar system runs out of resources. So that's the reason for his approach. I just thought it would be useful to show that.
Okay, let's see. Caleb.
So my question is whether it would be possible to have like a sort of dynamic approach to this so like it changes over time. So say like in 1,000 years, we've like colonized other planets. Like the human populations on those planets are ginormous, and we've reached like 1/8 of the capacity of the solar system, let's say. At that point, perhaps we could do a little bit of reevaluation, and maybe we could say, maybe we can give ourselves a bit more, maybe for the next 1,000 years. Maybe we get another like 1/8 for the next 1,000 years or something. And obviously we would have to slow our population growth, but maybe we could have like a dynamic system like that, where we're not sort of like, and I'm sure that like, considering what Catherine just said about like the statistical nature of this, I'm sure like that would be reasonable since it's not ideological. What do you think of that sort of proposal?
Yeah, I suspect that, I mean, it's going to be a dynamic process in any case, and our regulation of resource use is going to evolve over time. And I mean, I guess there are those who would argue that maybe it's going to evolve, to restrict our resource consumption anyway, that economic factors will just, as resources become scarcer or more difficult to access, that our consumption, there may be ecological or economic factors that reduce our consumption. So, maybe, but I guess the question is, are we really going to make a smooth transition to reducing our resource consumption, or are we going to grow exponentially until we've really outstripped the capacity to maintain our population and our society, and then go through some sort of an overshoot of the solar system's carrying capacity, if you will, and then collapse to what would be a worse condition than what we would have had if we had put in some constraints ahead of time. So, so I guess, yeah, I think it has to be dynamic, but I think what we need to start thinking about is how do we put in the constraints before we start bumping up against serious limits.
Okay, William?
Yeah, just a quick note. The International Seabed Authority has an interesting way of conserving deep sea resources that might be applicable. And when a company wants to mine an area in the mid-Pacific, say, they turn in their application, but they have to identify 2 similar sized areas that they are proposing to mine. And then the Seabed Authority picks one or the other. And then the one that they don't pick to be mined goes into a conservation trust. So it's sort of like dividing the cookie in half. The companies are very careful to make sure that both areas they pick have the resources that they want, because they don't know which one they'll end up getting. So that's one process that might be applicable in a situation for extraterrestrial use.
Very interesting.
Okay. Catherine, do you have your hand up again or no? Joe? You're muted, ma'am.
There you go. I already asked this question a bit in the chat, but I'll just repeat it here for everyone's sake. So perhaps this is a bit simple-minded, but when I hear the number 7/8, my immediate question is, why that number? Why 7? What is the actual justification for 7/8 over, say, 6/8 or 5 out of 8 or something like that? And I think this question isn't just to be cute, because obviously the difference between conserving 5/8 and 6/8 versus 7/8 or whatever the number happens to be is massive, right? There's a massive difference from that. So I guess I just wonder what is actually the justification for the 7/8 proposal qua 7/8, right, over some other fraction, because the differences are really material in terms of what we can do in our solar system and beyond.
Mm-hmm. Yeah. Okay. Well, I mean, the justification that Elvis and Milligan give is simply that when you are if you're growing exponentially and you've consumed 1/8 of the resources, you're 3 doubling times from consuming everything. So that's where they get that. It's just, and why is 3 doubling times important? Well, assuming like something like a 2% growth rate, that would be like 60 years. They would give you a doubling time of 20 years. And so that'd be 60 years until you're reaching complete depletion. And so they think that that's a reasonable time frame for the society to be able to switch gears to some other way of living in the solar system without continued exponentially growing resource consumption. But yeah, you can certainly argue that number and could choose a different threshold.
Okay, well, thank you very much, Alan.